Exercise 1D. Sums and products of functions. Again, you don't have to do all questions. It takes a long time to do. It's the analysis that you take out of it. And again, if you don't get it for the first time, chapter 7 does it again in 7D or something like that. Sums and products. Sums means add. Product means times or multiply. So you got functions that add together or you got functions that multiply to each other. You can obviously do quotients as well, but these are your two key skills. So definition, in order to add or subtract or multiply fractions or functions, they must first satisfy something. And this is your key definition. In order for sums and products of functions to exist, meaning if you type on a calculator or on Desmos and for it to actually sketch you a graph, that one has to occur. Okay, this one has to be true. And I'll show you on Desmos later to clarify that point there. But it just means that the domain of the first function needs to also be in the same domain as the second one. Okay, and then that's where you can add or subtract those two values. So note the way we write the sum and products of functions. So sums versus products. If this is f of x, we can say f of x plus g of x, which is actually the same as just writing f plus g of x. Sometimes they also put brackets in the first one to say it's f plus g of x because they're both in terms of x. Same thing with f of x times g of x. You can also write fg bracket x, and sometimes they write it with an extra bracket too. Okay, so this is that's all you literally need to know in terms of definition for exercise 1D. Now let's think about the logic. Why must I have this, right? Well, let's say I gave you this. Let's say f of x as an example. I said it's 1 on x. It's a rectangular hyperbole graph. Versus g of x, let's say I gave you root of x. One of the first things you should already note that if I asked you to sketch 1 on x, it has a horizontal and vertical asymptote, so it can't be 0, and y can't be 0, right? That's a rectangular hyperbole. Then I asked you to sketch root of x, which looks like this, which does include 0. If I now asked you to sketch the graph of f plus g of x, so f plus g of x, one of the first things in order to even visualize it, well, first, f plus g of x is the y value. Remember how we, back in year 9 and all that, we used to say y equals 1 on x, or we say y equals root of x. Well, then g of x represents the y values for root of x, and f of x represents the y values for 1 on x, and therefore f plus g of x is the y values for this function. So in order to get a y value, you have to be able to visualize. Let's see, if I put these top and top together, can you see on this side, if x was -1, I do have a y value for 1 on x because 1 over -1 gives you a value. But the problem is that root of -1 doesn't exist. So if you put it all in a line, it wouldn't make sense. Root of -1 plus 1 on -1, you can't do this one. That's undefined. If that's undefined, well, what value can you put in at x equals to -1? Where's the y coordinate? Doesn't exist. So you can't even sketch that graph. That's why this line makes sense. They're saying that both of them have to work, meaning they both have to share the same domain. So if you look at these two graphs, the root of x is from 0 to infinity. This has a domain of 0 to infinity. And this one technically is -infinity to +infinity, excluding 0. So if I looked at it, it's this yellow highlight region. That's where they're both in common, except for 0. So as long as I choose any number bigger than 0 for both of these graphs, not including 0, that's when I can get a graph. So I already know that's the region, and that's what this definition is saying. This definition is saying that both of them have to have the same x values that work. That way you can add the two y values. Okay? And same thing with times. Times means that you can times the two y values together. So your job for today in exercise 1D is actually for you to be able to analyze, okay, I can see the two y values in each graph. If I add them, what would it look like? Would it be greater, smaller? Would it be negative if I multiply them? That's the analysis. So chapter 1 is all about analysis. So that's why it's hard for me to teach you what to do, because every function is slightly different. You have to have the ability to imagine, if I sub in a negative number, what happens to the equation. That's the skill from chapter 1. Yeah? All right, so here's the first part of the exercise. I just chose an example. Example 16 from your textbook. Say f of x is root of x minus 2. And we know that, therefore, the domain is greater than 2 or equal to 2. And then you got g of x is 4 minus x, which that negative, if you've forgotten, that negative means it's a horizontal reflection. So therefore, it flips the other way. And it's asking for, what's f plus g of x look like? So here we go. What does this equal to? F of g is root x minus 2. And g of x, so plus g of x, which is root 4 minus x. Question is, you can't just write your answer like that. Because remember, for it to exist, we have to look at the common domain. So this one said x is greater than 2 or equal to, and this is saying x is less than or equal to 4. So which region, what's the domain for this graph? Because you have to define it. You can't just write the function without defining the domain. What would work? 2 to 4. And if that was something you struggle, you can visualize it, draw it. So this was from 2 onwards. That's f. G was less than or equal to 4. Should look like this. The only time that you can even add the y values has to be limited to 2 to 4. These are the only two regions. Each of these, you can add them together to visualize. Otherwise, this side is undefined and that side is undefined. So the only part they share is from 2 to 4. So here's my answer. You would say then x is an element of 2 to 4. And that is testing the first skill. Domain of f has to intersect with domain of g in order for you to have a sums or products of functions. Okay? All right. And then obviously this is just getting you used to, well, how would you work it out? If you now have the equation, you've defined it, f plus g of 3 just means you're substituting x equals 3 into the function. So here we go. This would now equal to root of 3 minus 2 plus root of 4 minus 3. And remember, 3 currently does fit into the domain, so that works. Here we go. That's root of 1 plus root of 1 as well. Root of 1 is 1. 1 plus 1 is 2. Okay, so I know at 3, I have 2. So technically, this center, where it was 3, it should have been 1. If I added the two values together, so at 1 plus 1, makes sense that the new graph should have a peak. And I know the domain only works from 2 to 4. In fact, if I had to roughly estimate this, you can see that the green light graph is going down whilst this is increasing. So if I add these two, it's getting closer and closer to 1 plus 1. So that means my graph should look something like this. And then vice versa. This one's getting smaller and smaller up until 0 plus whatever this number is should end up like that. So it should look something like this. So if I asked you, what does f of plus g of x look like? I'm pretty sure it'll be from 2 to 4, and it'll have this sort of like shape, roughly. And that's the skill. So what I'm teaching you there is not to memorize that, but is to analyze. Analyze what would it look like based on those key points and based on the definition. Cool, and that's the essence of 1D. Okay, and again, if you don't get what I'm sort of saying, you've got to practice it again in chapter 7. Yeah? All right, f of g, we can fill this one in, or you can fill it in yourself now. So this is really just saying root of x minus 2 times root of 4 minus x, and same thing, the domain would be the same for 2 to 4. And then this one would be essentially root of 1 times root of 1, which is 1. Okay? All right, let's get you to practice. Flip over the page. So I've done the liberty for you. I've sketched it all on one axis. I've got a f of x is root negative x plus x. So it looks like that red line. It doesn't really matter. It could have been just x as well. Actually, maybe I should... Wait, which one is which? Oh, no. Something's wrong. Sorry. Can you fix this line? F of x should be... That should be g of x, actually. Oh, that's so weird. All right. That's my mistake there. So based on this, it should be g of x is negative root x. So that means I wanted to say g of x is equal to negative root of x for x element of 0 to infinity. And I probably want to say f of x was equal to x. That's probably what I wanted to say. Yeah, this is garbage. That must have been a previous question or something. And it's h of x actually. There we go. And I want you to add the two. Did I do a mistake for the other one? Oh yeah, that should have been hg of x. All right. Here we go. You've got the red line, which is h of x, which is equal to x. It's a nice linear graph. And you've got g of x, which is negative root of x, which is a square root graph. If I were to add the two, so I'm asking you, what does g of x plus h of x look like? So sketch. Or g plus h of x. What does that look like? Do a rough sketch. Then we'll check our answers together. I'm going to write the answers up. Pause the screen. Once you've done that, have a go with the timesing. So what if I got you to multiply the two? Again, you're trying to look at the y values, find the common domain. What would the new graph look like, roughly? How do you know? What are some things you can analyze? Can't see my notes. Good.
I love the other stuff. All the other stuff. Chemistry, but yeah, I don't know. Maybe. Because all the other subjects, it's like 1 per lesson, maybe 1.5.
So it ticks off that skill, as I was saying. This bit here must mean the graph is from domain of h of x intersects domain for g of x. So that's the first thing that you're going to tick off. Then the analysis bit depends on what the graph and what they give to you in the exam in terms of scale. I usually look for key points. So I'm going to highlight the key points. Looking for any intercepts or any values with x equals 1. Those are usually the first starting points I do. So number 1, check domain. Number 2, find key points. Okay, and then number 3, it's the analysis. It's based on how strong you could do that. Okay, but that's 1D, and chapter 7 does it again. All right, have a go with the second one if you hadn't had time. Let's go. I'll give you about 2 minutes. Pause 2, 1. All right, it's recording. So you know it is in this domain. Fantastic. You know that you're multiplying them now. So I gave you, this was 1, that was 1, and this was -1. And one of the first things is knowing that makes it easier because we know that the two y values, if you multiplied these two together for that particular point, we know that a positive value times a negative value would actually end up being a negative. But coincidentally, 1 times -1 is actually this point. The other point we also know is the 0, 0. So that means both of them have 0, 0. And if you multiply the y values, it should also be 0. So the question is now, all right, so does it go further down and then back up? Or does it kind of loop out and then comes out? All right, because one of the things we know is it can't be a straight linear. Why not? What's the reasoning? Why do I know it can't be a straight line connecting 0, 0 to 1, -1? What's the reasoning, Leah? Yeah, this one does. But even when you're multiplying, how are you going to have a constant gradient if the other one's not going to be consistent as well? But number 2 is that this one's changing. So that's already a hint that it couldn't be from 0 to 1 crossing out. So it had to be either it's curving back up, which implies the number's going to get more positive over time, or it gets more negative. Now logic is all these red values are all positive. It's only getting larger positive, and all these values are all getting more negative. So positive times a negative is only going to be ever negative. So therefore, it should get more negative as we go. It shouldn't be reversing back because this is where they meet again. So there has to be at some point that equalizes, but it couldn't be straight. So it's either you curve back around or you curve back this way. So very likely the answer is this one. Something like that, roughly. Okay. So I don't know how steep or what the sort of graph looks like, but I assume it's something like that. But that's what I mean by analysis. So they'll give you different functions, and your job is to identify. So first one, find the domain. 2, key points. 3, analysis. And that's the main part of 1D and chapter 7D, I think it was. But that, yeah. So if you find that it's 1G, 1D, that's analysis. Pretty much all analysis there. 1E, 1F is technical, so knowledge and then applying skills. 1H, application, so extending it out into a scenario and then solving. That's pretty much it. ABC is just revision from last year. Cool, so that should summarize to you where should you focus your efforts and understanding as you're doing your revision. Don't just do all the questions for the sake of doing them, okay? All right, here we go. I'm going to stop the video.